Hi everybody, we are going to continue our notes today from functions in class that we started taking. Some of this is going to be repeat, but most of what I'm going to write is not. Right now what I want you to do is pause the video and look back in your notes from what we took in class today and answer these questions because you have the answers to all of them. Okay, so in your notebook, what is a function? A function has every input has one unique output. That's the most important piece that we will cover. Every input has one unique output, so there's no repeat x's. We don't care about the y's, but no repeat x's. Okay, write an example of a function. Well, you might have a set of coordinate pairs that are like 2, 5, or you could have made a table, 3, 8, and you could have even written like 4, 5. It doesn't matter about the y's, it's the x's that are all unique and all different. You could have written any numbers as long as they were all different. A non-function, it's a little bit easier to do. You could have had like 2, 5, 3, 8, 4, 5, and then like 2, 7. This is different because the x's, we have a repeat. So these two coordinate pairs are the ones that make it not a function. Vertical line test is the way that we test to see if a graph is a function. Is a function. Any vertical line should only pass the graph once. Everywhere, right? So a graph, an example of a function on a graph might be just like a straight line. Okay? And an example of a non-graph, a non-function, could be anything that has a vertical line. So a circle is the best example because it fits perfectly. Okay? There we go. Next slide. So let's talk a little bit more about functions. Functions, we have a lot of different ways we can write them. These are ordered pairs. Now this ordered pair, stop right here. Is this a function? Yes or no? No, it is not. Why not? Because of this guy and this guy, right? So what I'm going to do right now is I'm going to put this one in red to show that this is a bad one. We don't like this one. Okay. I could make a table. An x, y table, and have my points 2, 2, -1, 5. Now, a table is easier if it's written in least greatest, but this is fine. So if you redid it and did -1, 2, and 5, that would be better. And then I'm going to put this guy in red because this is what makes it a non-function. No, right? Now I'm going to graph it. On a graph, it's just as easy as graphing h point 2, 2, -1, 5. Right? The x's go left to right. The y's go up and down. 5, 2, and then 2, -4. Now remember, this is a function up until here. This vertical line right here is what makes it not a function. I don't care about the two that are side to side. Those are fine because we don't care about the y's. It's the x's that can't match. So this vertical line is not a function because of that vertical line. Okay, I'm going to skip this slide. Not a problem. Okay, so the vertical line test, let's look at it some more. I want you to pause the video and write whether or not these are functions using the vertical line test. Okay, so this one you should have written no, because look, and there's like a million vertical lines that don't pass it. This one is also a no, right? You can show it right there. This one, yes. All these vertical lines, they're only going through this graph once. Even where it gets really steep with the slope, it's still only once. Now this one is kind of hard to tell. This one's actually a yes. And the reason behind that is that these guys here are open circles. that means there's not actually points there. So the vertical line that goes through here, it only crosses this one. This guy, it's like saying it's greater than that number, so it doesn't actually touch it. Like when I say a number is greater than 3, but not equal to 3, it could be 3.0001, but it's not actually 3. So that one is, but this one is not. Because this, well, first of all, it overlaps there, but both of these are closed circles. So either way, it's not. And then this one's a yes. Okay. Last slide, I believe. Oh, no, 2 more. Okay. Functions and equations. Equations, there has to be a y. There has to be a y, and there can be no exponents on that y. There can be no x's attached to it. So it can't be xy, for example. It can't be not, it cannot be in a denominator. But there could be more than one. So you could have something like this, 2y equals 6, because that's really just y equals 3. So this is okay. Even this over here, if I have y equals x plus 2 plus 3y, well, that's okay because we could just combine those. These are like terms. So this is also okay because they're like terms. But xy is not okay. And you don't have to have an x. You could have an x, can have an x, can have x, but you don't need it. You don't need it, okay? You can have an x, but you don't need it. But you have to have that y in order for it to be a function. If there's only an x, not a function. Now, last slide. Okay, so let's talk about domain and range, because this is the part that's going to help you on your skill drill that's due tomorrow. The domain is all of the x values. And the range is all of the y values. And you just list them. So for our x values here, we would write domain, and it includes, and put this little like, that's terrible. Anyway, this little bracket. There you go. And we're going to list them from least to greatest with no repeats. If there are repeats, that's okay. We're just not going to list them. So our lowest one here is -1, and we've got 2 and 5. Those are the x values that exist. Now, we know that this one's not a function because there's multiple 2's, but that's okay. We're just listing the domain. So that's it. You just list the x values from least to greatest. And then the range is the same thing. The y values from least to greatest. So it looks like -4, 2, and 5. Now, they don't match up. It's just basically showing us the range of what's the lowest we would need on a graph and what's the highest that we would need on a graph. Now, this guy over here, it's pretty continuous, right? It goes on from this to this. These points and everything in between, they're all points. So listing the domain itself would be really, really terrible. So the domain, we're going to put the smallest value of x, which is, what does this say, 12, is less than or equal to x, which is less than or equal to, what is this, 19. So you're saying that the domain x is between 12 and 19. Now the range is, again, the y's. The lowest value of y that it looks like it gets to is 229. It's less than or equal to y, which is less than or equal to 642. And that's it, right? If it was a straight line that went on and on forever, so if I had, here's another example. Here's my coordinate grid, and here's my function. See how it's going on and on forever in both directions? Then we would say that the domain is -infinity to +infinity. It's infinite. And then the range, I think I'm doing this in the opposite color, but it's okay. The range is also negative infinity to positive infinity. It just goes on and on and on forever. Okay, that's it for your notes today. Make sure that you finish that function notation review that was due today, and you finish your skill drill that is due tomorrow. You have a test in 2 days, Wednesday, Thursday. If you need extra help, send me an email, talk to me. I'm available before school tomorrow. We can make arrangements for you after school tomorrow. And then I'm available Thursday before school. So find that time for the extra help for your test. Okay, guys, see you tomorrow.